What if you could teach a machine, not just to follow rules, but to understand your world, to predict what customers need before even they know it, to turn raw data into real action, not someday, today. But here's the part most people miss. AI isn't magic. It's not a shortcut. It's a process, a system, a blueprint. Think about any great software project. It doesn't start with code. It starts with a plan, a roadmap, a clear structure from concept to creation. AI is no different. Behind every smart assistant, every fraud detector, every personalized recommendation is a life cycle, a disciplined journey from a real-world problem to a machine that can learn, adapt, and decide. And today, I'll walk you through that journey, not as an engineer, not as a researcher, but as an architect of intelligence, one blueprint at a time. Because when you understand the life cycle, you stop guessing and start building with purpose. It starts with a problem, a real business need. Then, data validation, exploratory data analysis, EDA, feature engineering, feature selection, model building, hyperparameter tuning, model validation, model deployment, and finally, model monitoring and maintenance. This is the AI lifecycle. And once you learn to follow it, step by step, you won't just use AI. You'll create intelligence that lasts. Business problem. It all starts with a problem. So let's begin where all meaningful technology begins, not with data, not with models, but with a problem, a business need, a real one. You don't build AI to impress. You build it to improve something. Maybe your support team wants to reduce ticket response time. Maybe your sales team wants to know who's likely to buy and who isn't. These aren't just numbers. They're questions waiting to be answered. And so you ask, what decision are we trying to support? That question becomes your compass. At this stage, you don't write code. You write understanding. You sit with stakeholders. You talk. You listen. You translate business language into AI language. Not, we want to improve loyalty, but can we predict if a user will stop using the app within the next 14 days? That's clear. That's measurable. That is the start of intelligence. Because if you skip this part, you're not solving a problem. You're just training a model. An AI that doesn't solve a real problem isn't worth building. Data validation, the hunt for good data. So you've defined the problem. You know what you're solving. Now you go looking for the answers. And in AI, the answers live in one place, the data. But here's what most people don't realize. Data isn't born clean. It's not delivered in perfect rows and columns. Data is messy, incomplete, noisy. And if you don't stop to validate it, you're building your entire model on sand. You start asking questions. Are there missing values? Are dates in the right format? Do text fields contain junk? Are there duplicates? Is this column really what we think it is? Because data can lie. And it often does, silently. This step isn't glamorous. There's no AI magic here. It's just patience, attention, discipline. You look at every table like a detective, not just to find insights, but to catch the cracks. You use tools like Pandas, SQL, or even Excel. You write simple scripts. You build checks. You log anomalies, and you fix what's broken. You verify the source. Where did this data come from? Can we trust it? Because if the foundation isn't solid, no model will save you. Here's the truth. The smartest AI in the world, trained on bad data, becomes dumb. So when do you validate? Right now, before anything else, because this step doesn't just protect your model, it protects your credibility. Remember this, before you train a machine to learn, you train yourself to trust the data. Exploratory data analysis, EDA, looking inside the data. You've asked the right question. You've gathered the data. You've cleaned it. You've verified it. Now, you slow down. You don't rush to modeling. You don't jump to algorithms. You look inside the data. This is exploratory data analysis. But really, it's data storytelling. You're not just running stats. You're asking the data, what are you trying to show me? You start with simple questions. What's the average user age? What's the most common city? Do sales peak on weekends? And then deeper. Are there outliers? Are some users behaving completely differently? Are there strange gaps in time or unexpected clusters? You visualize histograms, box plots, heat maps. You look at how features relate to each other. You break things down. male versus female, Android versus iOS, returning users versus new. And in this moment, the data starts to talk. Maybe you discover that people who leave your app often stop engaging 3 days earlier. That's gold. That's insight. And it didn't come from a model. It came from observation, from curiosity, from taking time to understand what's already there. EDA is where great data scientists separate themselves because they don't just work with numbers. They learn to read them, to hear the signal in the noise. So when do you do EDA? Right after validation, right before modeling. It is the bridge between data and decisions. And if you skip this step, you risk building a solution without knowing what the real patterns are. Because here's the truth, models learn from data, but you learn from EDA. Feature engineering, turning raw into useful. Raw data is like raw material. It has potential, but not power. To make it meaningful, to make it usable, you need to shape it. This is feature engineering, and it's where intelligence begins to form. You take a single timestamp, a simple line in a log, and you extract a world of meaning from it. What day was it? What time? Was it a weekend, a holiday, a lunch break? Suddenly that one column becomes 5, and the machine has a clearer picture of what's happening. You do the same with text. You clean it, tokenize it, convert it into numbers. Maybe a review becomes a sentiment score, positive, neutral, or angry. Now the machine can feel tone. You do it with categories, one-hot encoding, frequency encoding. Whatever helps translate the messy world into something the model can understand. You create new columns, ratios like price per click, flags like first-time visitor, even domain-specific features no dataset will give you, only insight will. This step, it's not just technical, it's creative. Because here your job is not to build a model. Your job is to teach it. And every feature you create is a piece of knowledge you're giving the machine. Not just data, but meaning. You do this after you've explored the data. Once you've understood it, you do it before you train anything, because what you feed the model defines how well it learns. Think of it this way. Algorithms are the brain, but features? They're the language the brain speaks. So speak clearly, shape carefully, engineer with intention. Because the difference between an average model and an extraordinary one is almost always in the features. Feature selection, less is more. By now, your dataset is full. Dozens, maybe hundreds of features, each one telling part of the story. But here's the thing, not every feature deserves to be there. Some are noisy, some are redundant, some seem useful, but add confusion instead of clarity. That's where feature selection comes in. This is the art of knowing what to keep and what to leave behind. It's not just about reducing size, it's about increasing focus. Because when a model sees too much, it learns too little. It gets distracted. It overfits. It starts memorizing noise instead of understanding patterns. So you begin evaluating which features are highly correlated, drop one, which features have no variance, useless, which ones rank low in importance even in your best models. Let them go. You use tools, correlation heat maps, mutual information, recursive feature elimination, tree-based importance scores. But more than that, you use judgment. Because sometimes the data says a feature is important, but the business says it's irrelevant. This is where your understanding of the domain, not just the data, comes alive. When do you do this? After engineering features. Before training your final models. It's your last chance to clean the canvas. And why do it? To build models that are not just powerful, but elegant, efficient, easy to explain, easy to trust. Remember, great design isn't about adding more. It's about removing the unnecessary until only the essential remains. And in AI, just like in art, less is more. Model building, teaching the machine. This is the moment most people wait for. The point where the machine begins to learn. But what most people don't realize is this. If you've done the previous steps well, this part becomes almost effortless. Model building isn't the beginning of the journey. It's the reward for preparation. You've shaped the data, you've cleaned the noise, you've given the machine something meaningful to learn from. And now, it learns. You start with a split, training set, validation set, maybe even a test set for when the exam comes. Then you choose the brain, a decision tree, simple, interpretable, fast. A random forest, powerful, stable, balanced. XGBoost, tuned for performance. Or maybe a deep learning model, if the data calls for it. But you don't choose blindly, you choose based on your problem, your data, your goal. For classification, logistic regression, SVMs, ensemble trees. For regression, linear models, gradient boosting. For ranking or recommendation, collaborative filtering, matrix factorization. You let the need guide the tool, and then you train. The machine begins to form its internal understanding, finding patterns, learning relationships, one row at a time. It sees that users who churn often stop logging in. It learns that high bounce rates predict low conversion. And every time it's wrong, it adjusts, just like we do. You monitor loss, accuracy, recall. You run multiple experiments. You try different algorithms. And you keep asking the same question. Is the model learning what it should, or is it just memorizing? This stage isn't about perfection. It's about getting something that works, reliably, repeatably, on the data it's never seen before. Because that's how you know it's real, that it has learned something useful, not memorized, but understood. That's the difference between a model that just fits and one that can truly think. Hyperparameter tuning, finding the sweet spot. So your model is built, it runs, it predicts, it learns, but now you ask a new question. Can it be better? This is where we begin to tune. Every machine learning model has hidden dials, settings that shape how it learns. We call them hyperparameters. For a decision tree, it's how deep the tree can go. For gradient boosting, it's the learning rate, the number of trees. For neural networks, it's the number of layers, the batch size, the optimizer. These choices don't change what the model is, but they change how well it learns, how fast, how focused, how balanced. So you start testing, one setting at a time, then combinations. You try grid search, testing every combination. You try random search, sampling and exploring. Or you use smarter tools like Bayesian optimization that learn which paths are promising and which are not. You track results, not just performance, but stability. You look at how long training takes. You watch for overfitting. You document everything. This is not the most glamorous step, but it's where good models become great, because finding the sweet spot isn't about brute force, it's about balance. You're adjusting the strings of an instrument, not too tight, not too loose, until the sound is just right. When do you do this? After you've found a baseline model that works, not before, not during, but once you're ready to make it perform. Why? Because no matter how powerful your algorithm is, its true potential only shows when it's tuned to match the problem. That's what hyperparameter tuning really is. It's not about overcomplicating, it's about refining, about taking something functional and turning it into something exceptional. Model validation, testing it for real. So you've trained the model, you've tuned it. It performs beautifully on your validation data. But now comes the real test. Can it survive in the wild? This step, model validation, is where your AI proves whether it's truly intelligent or just memorized the past. You feed it new data it has never seen before, the test set. Why? Because in the real world, the data will always be new, and your model has to respond with confidence. You run the numbers, accuracy, precision, recall, F1 score, ROC AUC, but more importantly, you interpret them. You ask, does this model help everyone or just the majority? Does it make mistakes where it can't afford to? In fraud detection, a false negative could cost you millions. In healthcare, a false positive might scare a patient. So you evaluate with care, with context, with conscience. You look at the confusion matrix, not just as a chart, but as a window into where your model struggles. You dig deeper. Maybe it performs better for one group than another. Maybe it misses edge cases. This is where you fix bias, where fairness meets performance, and you go beyond numbers. You open the black box. You use tools like SHAP or Lime to explain what the model sees. You show it to stakeholders, not just to impress them, but to earn their trust. When do you do this? After training, after tuning, but before you ever consider deployment. Why? Because if you skip this step, you might ship a model that performs well in the lab, but fails in the field. And here's the truth. A model that hasn't been tested against reality hasn't really learned anything at all. Validation is not just a final check. It's the moment of truth. Model deployment. Bring it to life. After all the effort, all the analysis, all the training, testing, tuning, it's finally time. The model is ready, but now it has to leave the notebook and enter the real world. This is deployment, and this is where your AI stops being theory and starts creating value. You begin with a simple goal: serve predictions reliably. You serialize the model using Pickle, JobLib, or OwnAnX. You wrap it in an API, maybe with Flask, maybe Fast API, something light, something fast. You containerize it so it runs anywhere. Docker becomes your best friend. You test it locally. Then on a staging server, you measure latency, uptime, response quality. And then, piece by piece, you integrate it into a dashboard, into a product feature, into the workflow of a team. You build fail-safes, you handle edge cases, you make it robust, and you don't forget documentation. Because someday, someone else will take care of this model, and they'll need to know how it works and why it works. You don't dump it into production. You roll it out, slowly, carefully, A/B testing, shadow deployments, canary releases. Because even the best model in development can stumble in production. When do you deploy? Only after validation says, yes, this model is ready. And after your team is ready to own what happens next. Why is this moment so important? Because it's the first time your AI touches people. Not just data, not just dashboards, real decisions, real impact. The model is no longer a file. It's now a service. It's now alive. And this is where all the work finally becomes real. Monitoring and maintenance, keeping it smart. The model is live. It's integrated. It's making predictions. But your job isn't over. In fact, it's just beginning. Because AI doesn't age like software. It evolves. Or it dies. That's why we monitor. Every day new data arrives, new users appear, new behavior patterns emerge, and the world your model was trained on slowly starts to shift. We call this data drift, and it's silent. One day your model works. The next, it's making decisions based on a world that no longer exists. So you build a dashboard, you track performance, accuracy, recall, latency, you set alerts. When metrics drop, you know something's changed. You monitor inputs too. Are the distributions changing? Are certain categories disappearing or exploding? You listen not just to the numbers, but to the users. Are they happy? Are they trusting the predictions? And when it's time, you retrain with fresh data, with new insights. Sometimes you just update weights. Sometimes you rebuild everything from scratch. And if you planned ahead, it's seamless. You use Airflow or Prefect to schedule retraining. CI/CD pipelines to redeploy models, logging to track every version. It becomes routine, reliable, scalable. Because AI isn't a one-time event. It's a living system, like a garden. It needs attention, not daily panic, just steady care. Why do we do this? Because intelligence is not static, not in people, not in machines, not in the world we live in. And keeping AI smart isn't about rebuilding. It's about evolving, quietly, continuously, intentionally. From data to intelligence, the journey is yours. So now you've seen it, the full life cycle. From the very first question to a model that thinks, learns, and adapts. 10 steps, one path, not built on hype, not driven by buzzwords, but rooted in clarity, in structure, in the simple belief that machines can help us do better if we build them right. And here's the truth. You don't need to be a data scientist to start this journey. You don't need to be a mathematician or a genius or a PhD. You just need three things: curiosity, clarity, and the willingness to learn. Because the tools are open, the knowledge is everywhere, and AI, real practical AI, is no longer locked inside research labs. It's in your hands. Maybe you're an IT professional, maybe a fresher just starting out, maybe someone curious about the future. This process, this life cycle, belongs to you. Don't let the size of it scare you. Don't let the complexity stop you. Start small. Learn deeply. Build something simple. Build something that works. Because the future of AI isn't just code, it's intention. And intention lives in the hands of people who care enough to understand. So now I leave you with this. Take what you've learned today and begin. Not someday, today. Open a notebook, ask a question, clean some data, build something that matters. Because in this journey from data to intelligence, the next step is yours. The future of AI isn't in the lab, it's in your hands. In next session, we will discuss about the business problems in detail. How choose the business problem, the question raised by organization, and the question raised by AI scientists and the more. Stay tuned.